All right, so for graphing, so it's a lot harder. We know how to by hand graph some, common exponential functions. So we're going to convert our logarithms to exponentials, not exponents, but exponentials, and graph them. So for example, if I wanted to graph, let's say a log base 2 of x, well, one of the things I can do that's a little easier by hand is just graph x equals 2 to the y. Like I said, this is just the converted version. They are representing the same function. So in this case, we'd end up choosing our y's first and then solve for our x's. So just once again, saying that same thing here. Just a note here, note that the curve does not touch across the y-axis because we should have an asymptote there. So what I did is, like I said, I entered in my y's. So we know that this is also just going to give me the graph of log base 2 of x equals y. So I'm just using the converted version to do this. So if I want to find x when y is -3, well, that means I just have to do 2 to the -3, which is 1/8. So if I did the log base 2 of 1/8, that should give me -3. If I do 2 to the power of -2, that's a fourth. We've seen this before. If I do 2 to the -1, that's 1/2. If I do 2 to the 0, that's going to be 1. If I do 2 to the 1, that will be 2. If I do 2 to the 2, that will be 4. And if I do 2 to the 3, that would be 8. So if I start here at negative about 1/8, that means that y should be about -3. Then here we have, let me do the ordered pairs first. So that first ordered pair was -8, or sorry, was 1/8, -3. The second one is 1/4 and -2. So that's about here. And then we have 1/2, -1. So that one's approximately here. Then we have 1, 0, which is right here. Then we have 2, 1. We have 1, 2. Oh, sorry, 4, 2. And then we have 8, 3. So this is x equals 2 to the y, or you could say it is log base 2 of x equals y. This is a reminder, had I just done y equals 2x instead, we would have, it would look like this instead. 2. I got one of my points off there. What was that? There we go. We'll have that point there. Then we will have, it's gonna be like this. 2, 1. So we'll be 1, 2. There we go. I think I had that one off the last time. So like I said, that's just a reminder. That's what y to the 2x is going to look like. And everything is reflected across that line, x equals y, because they are inverse functions. So this and this are your inverses. So that's why we're kind of doing this backwards. We're finding the y's first, because what we're really doing is we're trying to find the inverse. That just to show you. Once again, that's what the two graphs look like together. So y equals to the x. So remember that here, I could not have y values that were negative, so I have a horizontal asymptote. So there's a horizontal asymptote here at y equals 0. But for x equals 2y, or like I said, log base 2 of x equals y, what we see here is that we have a vertical asymptote now. Where I can't touch the x-axis. So I have a vertical asymptote at x equals 0. So it's just another one of those examples of your inverses, or basically flipping your x and y's. So an asymptote at y0 now becomes an asymptote at x0. So those asymptotes also get reflected. Sorry, it's getting caught there for a second. So for you guys, first thing I want you to just work on is just doing finding, you got a log base 3 of x. So first, find the inverse function, or not the inverse, but write this as an exponential so you get your inverse of a 3x equals y. So you're getting your inverse of that, and then using graphing that with the y values first, finding the x's to get your function over here. After you do that, number 7, you could try doing the conversion again, but in this case, this would be easier to, now you know how to use those logarithm functions. Because this isn't in my calculator. I have to do a bunch of work to put this in a calculator and graph it. These ones, I can just use the whole log, because I have natural log on my calculator, and find those x and y points and graph them. So like I said, do this one first, try to do it with converting it to exponentials, and then try to do these ones by leaving the functions as logarithms. Okay, so for this one here, we're just going to convert this into 3 to the y equals x. So x is just going to be 3y. If y is negative 2, then we are going to have 1/9. If 3 is negative 1, then x would be, okay, let's try this again. If y is negative 2, x is 1/9. If y is negative 1, x is going to be 1/3. If y is 0, that means that x will be 1. If y is 1, that means x will be 3. If y is 2, x will be 9. And then just for fun, if y is 3, x would be 27. So obviously this last point we're probably not going to be able to graph. But we have a point 1/9, negative 2, 1/3, negative 1, 1, 0, 3, 1, 9, 2, 27, 3. So try to make a good guess about where negative 9 is. Or not negative 9, 1/9. 1/9, negative 2 here. 1/3, negative 1 here. 1, 0. Then we have 3, 1. And then we have 9, 2. And I can't put this last point in there. So I only get about this far. So remember, this shouldn't cross the y-axis. Unless we put some ships on it or something. But that's what's going to look like. Okay. So for number 7, like I said, because I can put a log into my calculator, or a natural log in my calculator, we're just going to try some points. So let's try negative 2. If I put negative 2, the natural log of negative 2 plus 3 is going to be natural log of 1. This is just going to be 0. So we have a point that is at negative 2, 0. Already we're kind of graphing in a weird spot. let's try, say, -1. If I put a -1 into my function here, then I would end up with 0.693 approximately, if we're going to do some rounding. If I put in 0, then I'm going to get roughly 1.099. If I put in 1, then I'm going to get 1.3. So I lost my place here. 387. So just to graph a few more of these points. So we see here at -1, I'm about here. At 0, I'm just a little above 1. At 1, I'm about here. So let's just look at a few other points to see what's going on. So let's say I'm trying -3. If I put in -3, this is going to be undefined. Because what I'm going to end up doing is natural log of 0, which we know is undefined. So that kind of gives me an idea, like, maybe this is where I should start looking for an asymptote. Which would make sense because we have this +3 in the inside, meaning everything shifts to the left by -3 units. So let's try something in between -2.5. That would be a -0.693. So I'm about here, negative. So let's tell me that point. So it's kind of giving me a little basis of what this is going to look like. So we kind of have a vague idea what this looks like. We know we have an asymptote about here. So it's a basic logarithmic function, but just shifted. So we shift to the left by 3 units, meaning that my vertical asymptote is also moved. And now it's going to be at x -3. Okay, so like it just build reminder of how these transformations were working. We did a little bit of work with these before. Okay, so let's do B next. Okay, so for here, what we have is like 3's on the outside, so this should shift everything up. And then we have a negative on the outside of the common log. This means we should have some sort of reflection. Once again, let's pick some points. So if we did things like -1, that'd be undefined. If I did 0, that is undefined. If I do 1, then I should get 3. So what we're seeing here is, once again, we have some sort of asymptote here. So let's pick something between 3 and this -0. So let's say do 1/2. I put it in one, oops. There we go. Messed up my calculator doing that. If I put in 1/2, I get 3.347. 347. So that's roughly here. So we're seeing that we're kind of like going up here. So let's pick a few other points. Let's pick 2. If I pick 2, that's going to give me 2.653, which is about here. So we're seeing this kind of shape going on. So like I said, we expect there to become kind of a reflection going on here, which is kind of what we're seeing here. So it's looking like we're coming up like this. We know that after 0, everything's undefined. So I probably have an asymptote here at 0, y x equals 0, which we should, because we look just at this original function, there should still be an asymptote there. So my vertical asymptote is going to be x equals 0. So it's going to be that y-intercept. Let's pick one more point to kind of flesh this out. Let's pick one's a little further out, like 8. What happens if I put 8 in? If I get 8, then I'm at 1.960. So just a tad below 2. So we're seeing that this is kind of like the general shape of this one. So we have a reflection. So usually they look like this. So we see that it's reflected over the x-axis, and then everything has shifted up because of that 3.